Good morning everyone. So today we'll be discussing IUPAC nomenclature of organic compounds. So in the last sessions we were discussing about the basic understanding of organic compounds and what do we mean by organic chemistry. Then slowly we have seen something like isomerism there, right? Okay. So now here I will be explaining the naming of organic compounds, because there are lot of organic molecules. Every day there is lot of molecules were synthesized. So in order to write their names or in order to remember their names, it is highly difficult, right? For example, I am saying formic acid. So formic acid is a common name for a particular carboxylic acid. Why we are calling that acid as a formic acid means it comes from the formica. Formica means what? Ant. So since it is coming from ant, we are calling that particular acid as a formic acid. Okay. Similarly, butyric acid I am saying. So this butyric acid comes from butter. Okay. So butyric acid, formic acid, how these names are given? So these are based on the origin, like from where they are getting extracted. So that is how the names were given. Okay. But remembering all, like there are some crores of names, remembering all their common names is highly difficult, right? So that's why we have a standard format of naming. Okay. We need to follow that standard rules in order to write the names for any organic compound. Okay. So therefore whenever you say that name following the IUPAC nomenclature, that rules, everyone can easily identify which compound exactly it is all over the world. Okay, right. So in order to understand organic chemistry in a better way, and if in your life if there is something related to chemistry subject, definitely you need to know this organic IUPAC nomenclature. Okay, without that we cannot survive, because without knowing the structure or name of a particular compound, how can you draw them, how can you make the reactions, right? So it is very important. I will tell you from very scratch, you just listen to me. Okay, right. Here, so in the last class I told you about alcohol, aldehyde, ketones, all these are what? Functional groups. So what is a like duty of functional group? That functional group only decides what type of character shown by the given organic compound. Okay, for example, a carboxylic acid group is there. For example, here I am writing for understanding purpose. So there is a compound like this with this carboxylic acid functional group like this. So acetic acid here I have written. So now since it has this kind of group, I can say the compound as acidic compound. What I am saying, it is an acidic compound. Whereas if the same number of carbons, let us say I am writing same number of carbons with one nitrogen atom here. Okay, now look at this, there is one NH2 group here. So these see carbons are there, along with that NH2 group is there. Now due to the presence of this NH2 group, this compound is basic. What I am saying, this compound is basic, whereas presence of this COOH group, it is acidic. So an atom or set of atoms together deciding the characteristic property of a given organic compound, right? So that's why we are calling that atom or group of atoms as a functional group. So what is the duty of functional group? That decides the characteristic properties of a given organic compound. Okay, adi acidic avvala, basic avvala, then reactivity ela undali. Okay, then physical properties, boiling point ekku untunda, takku untunda, melting point ela untundi. So all these factors are decided by the functional group that is present in the given organic compound. I hope up to here it is clear. So this is from yesterday's discussion, right? Yeah. So now let's move forward. Yeah. Okay, isomerism also I have discussed. So what do we mean by isomerism? I told you, so compounds have same molecular formula but they differ in their structure. For example, here they differ in the structure or arrangement of atoms in the three-dimensional space. For example, I am writing C4H8. C4H8 means I can write a formula like this. Check once, CH3, CH, double bond CH, CH3 I have written. Okay, next with the same formula I am writing CH2, CH, CH2, CH3. Okay, so now what you are observing here, so in the second case, in this B compound, the double bond pi bond is at the first carbon position, right? But in this compound, if you see, this is at the second carbon position. It means compounds have same molecular formula but differ in their structure. Differ in the structure means exactly that position of double bond is different, right now. So these are called structural isomers. What we can call them as structural isomers. Particularly they different in the position of pi bond now, so you can say them as positional isomers. Okay, the structural isomers again classified. So out of that, here what I am saying, it is a type of positional isomer. Okay, again I will be explaining them isomerism everything later, but as of now we will start our discussion on IUPAC nomenclature here. Okay, so now what it is an international organization to give or to write the names of a given organic compounds. Okay, right. So the rules to name organic compounds systematically, what is the use of this? To this organization proposing some set of rules in order to write the name of organic compounds. Okay, now what is the first basic rule here you need to know is identify the longest carbon chain. Okay, what I am saying, identify the longest hydrocarbon chain. It means, what do we mean by longest hydrocarbon chain? See, first of all let me show you something interesting here. So CH3, CH2, 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 CH3, I am writing like this. So how many carbons we have mentioned? 1, 2, 3, 4, 5, like this now. Now see, when I am writing this, it is taking too much of time. Okay, it is a time consuming structure. If I write like this, something like this, in a simple manner like this, so here also both AB of both of them are same only, but writing in this bond line notation is very easy than these condensed forms or this structural representation, right now. So that's why from now onwards we will prefer to write the structures in this manner, not in this. Okay, this is also correct, but we require to complete the question in a very lesser time now, and if we are writing in this way, it is very time like saving process. Okay, right. So now I will be explaining, you just follow here. So look at this, how many carbons are there here? 1. Okay, so this terminal group indicates that carbon here. So this terminal site, what it is called as a methyl. Both of them are same. What we can call it as methyl. We can call it as methyl. Okay, so same thing. This terminal also methyl only na, CH3 group. So this is also same. So both of them are indicating what? Methyl. Okay, remember this. Okay, next, in between these two, let us highlight that. Methyl, this is also methyl, you can understand. Okay, now if you observe, so on every corner here you are seeing now, so this is nothing but CH2 group. What is that group? CH2 group. Here also CH2, here also CH2. So CH2 group is called as methylene. What is that? Methylene. This is methyl. Okay, hope up to here it is clear. Now one more thing here you need to know is, only I have represented carbons, nothing else. Carbon and carbon-carbon bonds. How many bonds are there between two carbon atoms? See, between these two carbons, if you observe, there is one bond here. So that is indicated with this line. Again between these two, like that. So I haven't represented hydrogen atoms. So just only bonds are represented now. So you can simply call it as bond line notation. What is that? Bond line notation. Okay. Now how many carbons are there in this chain? Once count. 1, 2, 3, 4, 5. So 5 carbons are there now. See, whenever there is a 5 carbon, you can say it as pent. What you can say? Pent. Pent. 5 carbons are there, pent. So tell me, do we have any pi bond, like multiple bonds are there, pi bond, like alkene, alkane kind of thing is there? No, no, only sigma bonds are there. See, pi bond is, do we there or not means they will represent like this. If it is something like this, we can say yes, there is a pi bond. Okay, but there is no such kind of bond we are seeing here. So you can simply say pentane. What is that? Pentane. Okay, what is that? Pentane. Like this, if there is only one carbon, you should call meth. If there is two carbons are there, you can call it as eth. Like this, we have some set of numbering here. Just look at this. Write this table in your notes if you are not aware of these means. Okay, now how many carbons are there here? See, if one carbon is there, you can say that parent chain as meth. If two carbons are there, eth. Three carbons are there, prop. 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. Like this, we need to write the word root or the parent chain. See, select the longest carbon chain, identify the word root. So what do we mean by word root? See, I will tell you. First of all, understand what do we mean by longest chain. How many carbons are there in this check once? 1, 2, 3, 4, 5. Like this we have represented. So like this we need to give the numbering for carbon chain. Okay, let me show you something. Okay, now identify the longest chain in this compound, they will say. So look at this, you start numbering from any of the terminal side, but I should get maximum number of carbons in that chain itself. Okay, so if I start from here 1, 2, 3, so I can go this side. If I go this side, it becomes 4th. If I come this side, 4. Again, if I go this side, 5. If I come this side, again 6. So which is longer chain? So this chain is longer than this because it is stopped at 4th carbon only. Still going up to 6. So this is our longest carbon chain. Okay, hope it is clear what is mean by longest carbon chain means. Okay, after identifying longest carbon chain, then whatever the side chains we have, consider them as substituents like a branches. Okay, so now we have a branch at third carbon, right? Okay, this third carbon paina oka line unna chudandi. So that line indicates methyl group. What group it is? Methyl group. Okay, every terminal indicates what? Methyl only, like this. If there is only single bond, you can indicate it as methyl, CH3. Okay, now what is its name becomes is, you can simply write how many carbons are there in the parent chain, the longest chain? 6. If there are 6 carbons, what is the name? Hex. Okay, first you write hex. Okay, this is fine. After writing hex, now look, any multiple pi bond or pi bonds are there, any multiple bonds are there? No, no. So all of them are sigma bonds only. So hexane you can say, hexane. This is fine. Sir, you have represented 6 carbon, that is fine. So what about this extra branch here? Yeah. So when we are writing the names, first indicate the branch position and the name of that branch. So what is the position of branch? Third position. No? So 3-methyl. What is the name? 3-methyl hexane. What is the name? 3-methyl hexane. Like this, you need to write the IUPAC nomenclature. Now tell me for this. Yeah. So what will be your name, expected name for this given organic compound? Based on your understanding, please tell me in the comment box. Okay, so now tell me what is the name. So you just identify the chain here, 1, 2, 3, 4. That's it, na? Even if you go this side also, it becomes 4. Okay, like that you first identify the longest chain. After that, look at the extra branches that we have. This is a parent chain, you can say. That the longest carbon chain is called what? Parent chain. What is that? Parent chain. Okay, that parent chain name we are writing now, that is called root word or word root. Okay, so that parent chain name should be called as what? Word root or root word. Okay, this is fine. So now whatever the extra branches are there, like extra carbons are there, see at second position we have one methyl group over there and here also. So what are the positions we have? 2, 3. Okay, 2, 3, 2 methyl groups are there now. So dimethyl, 2, 3, dimethyl. Okay, 2, 3 dimethyl, bute, because 4 carbons are there. If 4 are there means bute. So only single bond, sigma bonds only there now we have here. So butane, that's it. Like this you need to write the name. Okay, so now what is our root word? Bute. So bute is our root word now. So anything we are writing before it is called prefix. What is that? Prefix. Okay, anything that we are writing after the root word is called suffix. Okay, listen to me properly. Anything we are writing for that root word, before it means prefix, after it suffix. I hope you know, you have studied that in English grammar also. So whenever you are writing IUPAC nomenclature, first write word root. It means that parent chain, how many carbons are there now, that is what your parent, like word root. Okay, if longest chain lo any carbons unnayo dani rastunnam kada, so that is called as word root. Okay, if you are writing any branches, extra branches, that should be mentioned in the prefix ante ikkada, it side. Okay, these prefixes are of two types, secondary prefix as well as primary prefix. How many we have? Secondary prefix and primary prefix. Okay, and if you are writing anything after root word is called suffix. So suffix also primary suffix, next secondary suffix. These are the two things you need to know. Okay, now again remember, name start with secondary prefix, ends with secondary suffix. 2, secondary, like that you can remember. Sir, what is this secondary prefix, primary prefix, all these things? Yeah, I will tell you, don't worry about that. Here I am writing a compound like this. Okay, at some position, at this position we have a branch. Next compound. Yeah. So what makes the difference between A and B? What makes the difference between these two? So look at this. What is the word root we have? How many carbons? Longest chain here? 1, 2, 3, 4, 5. Okay, like this we have 5 carbons. Even if you count in the cyclic ring also, 1, 2, 3, 4, 5. Like this now. So both of them contains 5 and 5. So if we have 5 chains, the longest chain means pent. Okay, all of them are single bonds only, no multiple bond is there. So pentane only. For both of them it is pentane only. But it is not saying which is open or closed, right now. So that is why we need to use these prefixes here to get that clarity. Whether the chain is open, whether a compound is open ring or open chain or closed ring. Okay, like that. So how many are there? 5 over. So at second position we have methyl group. Okay, so you can simply write 2 methyl pentane for this particular compound. Okay, when it comes to this, here also methyl is there and pentane it is also, but it is in cyclic form, not chain form now. So you should call it as 2 methyl, same, not 2, first position only we have methyl na? So 1 methyl cyclopentane. So what makes the difference here? So if you see the word root pent, perfect. Ane, suffix as it is, ane and ane as it is, no issues with that. But this side if you observe, there is some difference. Okay, now I have used two things here. Before the root word, I have used two things. One is to indicate the branches and another one is to indicate what type of compound, open or closed, like cyclic compound, like that na. So this secondary prefix and primary prefix are there na. So the primary prefix says about whether the compound is open or cyclic. Okay, so what are the prefixes we will be using here? Cyclo. If the compound is cyclic, need to use cyclo, or sometimes it is having 2 cycles, then you can say bicyclo, spiro, this kind of things are there. Okay, next, what about this secondary prefix? Secondary prefix says about what is the substituent we have, like branch, substituent. So what is a branch? Here we have 2 methyl na, like that. If there is ethyl, yeah, ethyl, methyl, any alkyl groups or any other halogens or any substituents are there means you write it first mentioning its position. Then next indicate if it is open sign, no need of writing any primary prefixes, but if it is a closed sign, must be indicated with cyclo. Okay, then write the word root, then next indicate what is a suffix here. Again sir, two suffixes you are mentioning here. Yeah, so two suffixes, why I am writing here means you just listen this what I am saying. Okay, so now what makes the difference between A and B, structure A and structure B? Okay, so if you observe structure A, so this is one carbon, second, third, fourth. So 1, 2, 3, 4. Here also 1, 2, 3, 4. So almost looking same now. How many carbons are there? 4 carbons. So 4 carbons are there means you can simply say root word as but. Okay, after writing but, next. Do we have any substituents? No substituent. So this functional group is called carboxylic acid. What is this functional group called? Carboxylic acid. Okay, so in the given compound, if there is any functional group, then the name of that compound should end with that functional group. Whatever the functional group we have, that should be written as a suffix. Okay, so but, and it should be indicated as carboxylic acid. Now you should write it as oic acid. What is that? Oic acid. Oic acid. Okay, so but, okay, but, after that two suffixes should be there. See, primary suffix, secondary suffix I am saying. But, do we have any pi bond in the given compound? No pi bond, only sigma bond. See, like CC single bonds only there now, but here we have a pi bond. So but, there also but, here also but you can write first. Okay, but you can write. After writing this, but, only single bonds now, butane. Butane, okay, and oic acid, butane, oic acid. Okay, normally what we will write, butane means E should also come now. Let us write like that, oic acid, butane oic acid. Okay, like this you can write for the first compound. For the second compound, there is a double bond like pi bond here. But, alkenes, now these two bonds are there means butene. Okay, butene oic acid, butene oic acid. Okay, now if you observe, we'll show you something to do here. So what is the position of bond here? Second position now, so that position also should be represented like but 2-ene oic acid, but 2-ene oic acid. Next thing, if you observe here, two ovals are there continuously, butane and oic acid. So remove this E from here. So you can write it as butane oic acid. That's it. For this one also remove this E here. So but 2-ene oic acid. So after the root word, after these root words, how many suffixes we have seen? Two suffixes. One is saying about what type of bond we have, whether they are alkanes, alkenes and alkynes. Right now, so here it is an alkane chain, so ene. Here it is an alkene double bond chain, alkene chain, so ene. Alkene, ene. Okay, so that is what the primary suffix says about whether the compound is alkane or alkene or alkyne. Okay, and the last secondary suffix, that is the last one, says about what type of functional group we have, what is the main functional group present in the given compound. Carboxylic acid now, so that's why you are writing it as oic acid. Okay, here also oic acid. Hope the discussion is clear. Right, now I will be giving you two more examples. You just write the name. Okay, in the same way you write the name. Okay, write the name for this compound. Just try. Just try. If you have any confusion, let me know. Yeah, so once again let me explain this 2 again, because someone is asking in the comment box. See how many carbons are there in the chain, parent chain? 1, 2, 3, 4. Here also 1, 2, 3, 4 carbons are there. So what is the main word root we should use? The number of carbons are there na, that you should indicate, like if 1 carbon with 2 carbons, it like that. So 4 carbons are there, you write it as but. Okay, write it as but. After that, so if you are writing anything after word root, then you should call them as suffixes. So we have 2 types of suffixes, primary suffix, secondary suffix. First write primary suffix. So what is that primary suffix means? Whether the compound, primary suffix means whether the compound is alkane or alkene or alkyne, that you need to represent first. After that, secondary suffix here. So what do we mean by secondary suffix? What is a functional group we have? Like see, this is COOH functional group. So the name of that compound should end as oic acid. If the functional group here it is carboxylic acid, name should be written as oic acid. Okay, what is that name should end as oic acid, oic acid. Okay, hope up to here it is clear. Now look at this again, but. Okay, this is an alkane chain, that's why ane. Okay, here you have a pi bond, that's why it is ene. What is the position of pi bond? Second position. So but 2 ene, 1 2 right now. So second position pi bond is there. So but 2 ene. Okay, but 2 ene. Next here but ane over. Next secondary suffix. What is the functional group? Carboxylic acid. That's why it is named as oic acid. Here also named as oic acid. Okay, so when you are writing ene, generally we will be using this kind of spelling. But after ene, we again got an oval here, O and E right now. So remove this E, no issues. Okay, but 2 ene oic acid. So here but ane oic acid. That's it. Okay, hope up to here it is clear. If you still have any confusion, please let me know. Yeah. So if no confusion, let us move forward with this particular compound. So try, everyone please try this. Yeah. So from where I should start numbering? From this side, because this is our functional group right now. So 1, 2. If I go this side, 3, 4 it becomes. But if I go this side, 3, 4. Yeah. So from which side I should go then? Both of them are 3, 4, 4 only. I will suggest you to go this side. Why? Because there is extra carbon here, branch. So if same number of carbons are there, then consider your parent child which is having more number of branches. Once again, if same number of carbons are there in the parent chain, 1, 2, 3, 4, this side also 3, 4. So then which one I should consider as parent chain? This one or this one? How can I know that? Yeah. So the one which is having more number of branches, consider that as your parent chain, not this one. This one not having any branch, but here we have an extra branch. So this is the parent chain. Okay, done up to here. Okay, now this becomes 2 carbons, means 1, 2. So ethyl. Okay, at what position we have ethyl? Second position. Right now at second position we have ethyl. So write it as 2 ethyl. Next 4 carbons in the chain. Okay, at third position we have methyl, 2 ethyl, 3 methyl, 2 ethyl, 3 methyl. Okay, next over, this branch is over, this branch also over. So next write the parent chain. But, only sigma bonds are there, no pi bond. Okay, butane, first position oic acid, butane oic acid. That's it. So this is your final name. Okay, hope the discussion is clear. Okay, so now generally you should get one doubt. What is that one doubt here is, sir, what I should write, whether I should write it as 2 ethyl, 3 methyl or 3 methyl, 2 ethyl butanoic acid. Okay, you should also write the 2 names in your notes and you just cross this second name that we have written now. Why? Because always follow alphabetical order for the substituents. Once again, when you are writing the substituents, which should come? 2-methyl should come or ethyl should come? How do you decide that? So decide it using the alphabetical order of these substituents. Here it is E, here it is M. Which letter comes first in alphabets? Write that name first. Okay, so ethyl, E comes first now. So ethyl, methyl, not methyl, ethyl. Okay, so what I told you, follow alphabetical order. alphabetical order for substituents, for substituent naming, substituent naming. Okay, hope it is clear. So first write ethyl, then write methyl butanoic acid. Okay, right. Someone is asking, sir, please read it in Hindi. Watching will increase. No, fine. See, I am not using very big English terminology here. You can just follow that so that everyone can understood. Okay. So this is the basic structure of IUPAC nomenclature. What is it? First, I told you to write root word. Okay. After writing root word, write the secondary suffix, primary suffix, next secondary suffix, and before that primary prefix, secondary prefix. Again saying start with secondary, end with secondary. Here prefix, there suffix. Okay, hope this is clear. Either make a note of it or take the screenshot of this. Okay, so that it will be useful for reference purpose. Okay, right. Next. Okay, can you write the names for this first compound? It looks very big, but it is easy to write. Okay, so from where I should start numbering? From which side? Yeah, I can start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this we can write. Okay. So now at second position, sir, why you are giving from this side? Why not from this side? Let us give from here also. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So both of them give same number of carbons. Anyways, we know that. But tell me whether this orange color is correct or this red color one is correct. So I go with this orange color. Okay, why orange color is correct here? Because the substituent positions, whatever you are writing the substituent position, they should get lowest number. What they are? They should get lowest number. Okay, in order to get lowest number, you need to give the numbering from substituent side, not from the other side. Okay, so this side we have substituent now, so start numbering from this terminal, not from this terminal. See, if I give from this terminal, what are the positions we have substituents? At second position, at fourth position, at sixth position we have, right? Yeah, so if I come from this side, see, if I come from this orange color side, first 2, next 4, next 6, that's it. These are the 3 branches, okay, as per this thing. If I come from this side, this red color side, so position here it is 5, here it is 7, here it is 9. So what is the total sum we are going to get? 16, 21 almost, right? But here if you take, it is only 12. So which is lowest number, least sum rule where we are getting, these are lowest numbers and sum is also less. So that's why prefer numbering with this lowest number, not in the other way. So that's why the name becomes here 2, 4, 6. What are the substituent names? Methyls only now. So how many methyls we have? 1, 2, 3. So trimethyl 2, 3, 2, 4, 6. Trimethyl. Okay, trimethyl. In the parent chain, how many carbons are there? 10. So trimethyl decane. What is that? Decane. So that's it. This is how you need to write the name. Okay, hope this is clear again. Yeah. Let me give you one more example. Yeah, so can you write the name for this? Can you write the name for this? From where I should start numbering? Yeah, look at this. Even if I come from this side, let us say this is A side. I am coming from A side and this is considered as B side. Okay, so this is 1, 2, 3, 4, 5, 6. Okay, from A side, what are the substituents we got to know? One is second position, other one is third position, other one is fifth position, right? Yeah. If I come from B side numbering, 1, 2, 3, 4, 5, 6. So what are the B side numberings? We have 2, 4, 5. So which is lowest number here? We are going to get this side only, because 8 plus 2, 10, and there it is 9, 11. So which is smaller side? This side. So A side numbering is correct, not from the B side. Okay, this is how you need to decide the numbering of the given compound. Okay, it's very important. We can expect direct questions from this discussion itself. Okay, yeah. So guys, till now whatever we discussed, if the things are clear, just hit on the like button or mention in the comment box clear. Okay, if you have any concerns or any confusions, please mention in the chat box. Okay, so now tell me, what is the name of the compound it becomes? So at second position and fifth position we have methyl. Second position, fifth position we have methyl. At third position we have ethyl. See, 1, 2. 2 carbons means ethyl. So I told you to write the name by following alphabetical order. So ethyl comes first with its number. So 3, so third position we have ethyl, na? So 3 ethyl. What is that? 3 ethyl. Done. 3 ethyl. Next 2, 5 dimethyl. What is that? 2, 5 dimethyl. Okay, after this 2, 5 dimethyl, how many carbons are there in the parent chain? 6. 3 ethyl, 2, 5 dimethyl, hexane. That's it, hexane. So this is the name of the compound. Okay, clear guys? Any confusions? Okay, then next. We'll come to this later. So when you are writing the names for cyclic compounds, what I told you, that cyclo should be indicated, like this is the structure of naming. What I told you, first identify the word root. Okay, before writing word root, look at the prefixes we have. So if the compound is cyclic, mention it as cyclo. Before that you mention the branches. Here methyl is there, na? Something like 3 methyl, 4 ethyl, something like that, whatever it is there, write the substituent branches. Next indicate cyclo. Next word root, how many carbons are there in that cyclic ring, parent chain. Okay, 6 are there means hexane. Okay, hex. After that indicate whether it is an alkene or alkyne. How can you know that? Identify whether only sigma bonds are there means ane. If at least one pi bond is there means ene. Okay, if a multiple bond, something like this, if it is there means ine. Okay, multiple 3 bonds are there now, so it becomes ine. Okay, now if there is any functional group, write here at the end. Okay, now I will be showing you, just follow this. Okay, anyways, we can do it with this example itself. Okay, so it's a cyclic ring. Yeah, we are clear with this, it is a cyclic ring. After writing cyclic ring, how many carbons are there in cyclic ring? 6 carbons are there. But from where we should write the numbering? See, this is methyl, ethyl. Which alphabet comes first? Both of them are alkyls only, no? So nothing like priority here. So just follow alphabetical order. Ethyl comes as first now, so E comes first now, so write one number here. 2, 3, 4, 5, 6. Okay, 5, 6. Like this you can go. Okay. So at first position ethyl, so that's why 1 ethyl. At third position methyl, 3 methyl, cyclohexane. That's it. This is how you need to write the name. Okay, cyclohex. So only sigma bonds ane. If at least one pi bond, ene it becomes with its position. Okay, right. Now let me write few more examples here. Yeah. So how can you write the name for this? So first of all, tell me whether it is a cyclic or open chain. Yes, cyclic. Okay. Now what are the positions we have? Okay, don't scare by looking at the structure. These are very simple. Okay, so at what are the positions we have here, here and here. But from where I should start numbering? You should start numbering in such a way to get lowest numbers to the substituents. Lowest numbers to the substituents means I should start with maximum substituents position here 1, then it is 2, then it is 3. Sir, I will come from this side. No, don't come from this side, because if you are coming from this side, your substituent getting bigger number. Don't come from this side, come only from the substituent side, like this, 3. Okay, this is become 4. Okay, so parent chain has 4 carbons, it means you should write it as bute. Any pi bond is there? No, butane. Okay, tell me whether it is cyclic or open. Cyclic. Cyclo. Okay, and what is the positions of branches? 1, 2, 3. Okay, at first position how many branches are there? 2 branches. What they are? Methyls. Second position also methyl. Third position also methyl. So total how many methyls? 4 methyls. Okay, what are the positions? 1 comma 1 at first position, 2 at second position, at third position. 1 comma 1 comma 2 comma 3. How many total? 4. So tetra, methyl. What is that? Methyl. Cyclo, butane. That's it. So this is how you can write the name. Hope this is clear, guys. If this is clear, just click on the like button. If not, just listen to me. Once again I am explaining. So when you write the naming for cyclic compounds, count number of carbons in the parent chain. So parent chain is our cyclic ring, right? Next, how many carbons are there? 4 carbons in the cyclic ring, 4-membered ring, that is cyclobutane. Okay, now what are the substituents we have? First position 2 carbons, 1, 2. So 2 of them are methyls. Second methyl, third also methyl. So 4 methyl groups are there. So first write the substituent names 1 comma 1 comma 2 comma 3 tetramethyl cyclo, because cyclic compound it is cyclo, suffix prefixes are over. Next root word bute, cyclobute, only sigma bonds are there, butane. Okay, right. Next, let me give an example of alkene also so that you feel clear about this. Okay, so now if you observe, what is the scenario here? You have how many carbons in the given compound? 1, 2, 3, 4, 5. So 5 carbons are there, means pentane, and cyclic form now, so it is called as cyclopentane. What is that? Cyclopentane. Okay, now tell me whether it is ane, ene or ine. Yeah, so there is a multiple pi bond here. Pi bond is there. How many pi bonds? 1 pi bond between these 2 carbons. So it should be called as alkene. So like pentene. So we have a prefix here, primary prefix, that suffix here, primary suffix. Okay. So even if you do not remember or getting confused between suffixes, prefixes, just ignore them. What I told you, if you are writing anything about bonds or functional groups, write them at the end. If you are writing anything about substituents like alkyl groups, chlorines, bromines, write them here, prefixes here before the word root. Okay, done. Okay, so cyclopentene, cyclopentene, pentene. That's it, pentene. That's it. Okay, now let us make it more clear with small changes. Like this I have mentioned, and along with this, okay, yeah. So now what I will do is, here I will be numbering it. Okay, methyl group. So what could be the name for the compound? What could be the name for the compound? So from where I should start numbering? From here or from here? So remember, whenever there is an alkene or alkynes, your numbers should be given to that carbons first. Okay, from where I should start? From here, here, or from here and then here. So always go with the substituent least number. So come from above side. So 1, 2, 3, 4. This is 5. So tell me now, what will be the name? Okay, so 1 methyl, it becomes 1 methyl, cyclopentene, pentene. That's it. That's it. This is how you need to write the name. Okay, hope the discussions are clear. If you have any confusion, please let me know. Yeah, let's move forward. Yeah, so now till now we just seen like without any functional groups, almost like alkanes and alkenes only we have seen. Now sometimes we will be having functional groups. What do we mean by functional group? I discussed this already. So that group decides the characteristic property of the given organic compound, right? So when we have different functional groups, how we are going to write the name for the compound? For example, here I'm writing here a carboxylic acid group, and here one hydroxy group, and here one amino group. So which should be prioritized first, or how can you write the name for this? So this kind of questions generally we see in the exam. Okay, now read this. A functional group is an atom or group of atoms which characterizes the chemical reactivity of a molecule. Okay, very important. Okay, so now the order of decreasing priority order of the functional groups, it means this is also set by IUPAC only. So what they are saying is, when you have multiple different functional groups, you should follow this order of priority. First give the priority to carboxylic acid, then next sulfonic acid, next ester, acid halides, acid amides, next cyanides, nitriles, you can say aldehydes, ketones, hydroxy groups, next thiols, next amines, alkene and alkyne. Okay, so now I will tell you how to practice or how to remember all these things in the upcoming sessions, but based on this you need to prioritize them. So as per this, who is prioritized there? Look, there is a COOH group. This is a carbon OOH group. So first, after that we have, that is first carbon. Next definitely it becomes 2, 3, 4. That's it. We have numbered it. Okay. So now how can we write the name? Okay. When you have identified the priority functional group following this order, that priority functional group should be indicated as suffix. What is a suffix? The priority functional group becomes suffix. That is what we can say principal functional group. What do we mean by principal functional group? In the given organic compound, the topmost prioritized functional group is called principal functional group. Okay, this is our principal functional group. Fine. Okay, so whatever the remaining functional groups are there, they just becomes prefixes. They just becomes like branches only, like prefixes. Now when we have hydroxy like OH group, you should write its prefix as hydroxy. I will tell you all these things. Just take this as an example. Hydroxy. When you have NH2 group, you write it as amino. Okay, what is that? Amino. Okay, write them as prefixes. See, first count number of carbons in the parent chain, 4 now. So you write word root as but. Okay, over. So before word root we need to write the prefixes. Now what are the prefixes we have? Hydroxy and amino. Which alphabet comes first? Amino. A comes first. So 3 amino. Right, 3 amino. After that 2 hydroxy. 2 hydroxy. 2 hydroxy. Next but. Okay, after writing but, so there is no pi bond, like there is nothing like alkene or alkyne, only sigma bonds we are saying, CC sigma bonds in the alkyl group chain, right? So butane. Okay, ane, functional group suffix is oic acid. Oic acid, that's it. So 3 amino, 2 hydroxy, butanoic acid. So this will be the name for the given organic compound. Okay, hope the discussion is clear. If not, just go back and watch it once again. It will be clear to you. So whatever we discussed till now, all of them are very important to understand the IUPAC nomenclature of organic compounds. Okay, whatever the remaining things are there, we'll be explaining in the next session. Just stay connected with this NEET World channel. So until that, you just go through this kind of table. So if you have anything related to IUPAC nomenclature or any NCERT books are fine. Okay, you just go through them. If nothing else, you just take a screenshot of this, go through this list of functional groups. In the next class, I will be explaining them and how to write the names, and we'll do some PYQs also. Okay, so thanks for watching. Stay connected.